Okay, good afternoon, students. Now I am going to start the class, and you listen very carefully. And little topic is pending in the dual nature that I am going to complete now. And tomorrow we will start the next chapter. Okay, atoms. Today I am going to continue the dual nature. The last topic, the very little topic is pending. Okay, I will complete. That is, in the last topic we discussed about the de Broglie hypothesis. Okay, in the de Broglie hypothesis, the moving particle behaves like a wave. Okay, photoelectric effect phenomena is explained based on the particle theory of light, and interference diffraction is explained based on the by considering the light as wave. That means finally that the light has dual nature. Then how the light has dual nature like that matter also has dual nature. That is a de Broglie hypothesis. De Broglie hypothesis is that nature loves symmetry. Light has dual nature means our matter also has dual nature. Then the wavelength associated with the moving particle, he gave one formula, right? The next topic is Heisenberg uncertainty principle. Heisenberg Heisenberg uncertainty principle. What is Heisenberg uncertainty principle? It was very simple. Okay, I think you learned in the chemistry also. Is my voice and picture is it clear? Everything, students? Okay. Heisenberg uncertainty principle. Heisenberg uncertainty principle is that the moving particle behaves like wave. Its wavelength formula previously we studied. M mass of particle if it moves with velocity v. The wavelength associated with the wave is moving particle is lambda is equal to h by mv. This mv is the momentum. Then we write as momentum is p. From this we can also find out the momentum also. But Heisenberg uncertainty principle is that whenever a particle, for example, electron is moving, then one wave is associated with this electron. One wave is associated with this electron, moving particle. Okay, and that wave is called as the matter wave or the de Broglie wave because wave is associated with the matter particle. That's why it is called as a de Broglie wave. And the de Broglie wavelength formula is this one, that is lambda equal to h by mv or h by p. And now here, the thing is that when electron is moving, this is considered as a wave packet. It's a wave. Wave packet means group of wavelengths, and this is a wave packet. In this wave packet, here electron is moving. It is very difficult to at any instant. It is very difficult to measure the accurate position and accurate momentum of the uh, electron simultaneously. Okay, this that is the Heisenberg uncertainty principle is that one only. We cannot measure its position accurately. We cannot measure the momentum also accurately in the wave packet. Right? Wave packet means it is a group of wavelengths. Okay, right. That statement I will give. It is not possible. It is not possible to measure both position and position and momentum position and momentum of of an electron or any other particle. Okay, at the same time, exactly. Okay, it is very difficult to measure the position and momentum. For example, if delta x is the uncertainty in the measurement of position, uncertainty in the measurement of position. That means you cannot measure the position accurately. Its position is always changes. Okay, the change in position is we can consider as delta x. We cannot measure the accurate position. There should be some error in the measurement of the position. Okay, delta x is the uncertainty in the measurement of the position. Delta x is the uncertainty in the measurement of position. Uncertainty in the measurement of position, and delta p is the uncertainty in the measurement of momentum. Uncertainty in the measurement of momentum means we cannot measure certainly momentum. We cannot measure the certainly position of electron. Okay, uncertainty in the measurement of momentum of electron, momentum of particle. Let me say moving particle behaves like wave. That moving particle position and that moving particle momentum we cannot measure accurately. There is some uncertainty is there, there is some error is there, there is some change is there, right? That uncertainty in the position and uncertainty in the momentum is delta p. Both we cannot measure. There should be, if you want to try in any time, then there should be some errors. Then according to Heisenberg principle is that delta x into delta p, it is nearly equal to the h by 2 pi, where h is the Planck's constant. Delta x is the uncertainty in the measurement of the position, and delta p is the uncertainty in the measurement of momentum. And this formula we can also write like this. That is delta x into delta p we write as mass into delta v. We can is equal to h by 2 pi. There is no change in the mass at here. Yet the change in velocity we write here. Then delta x into delta v is equal to, we will get as h by 2 pi m. In this, m is the mass of the electron. M is the mass of the electron. Okay, h is the Planck's constant. M is mass of electron or any particle. Okay, and in this delta v is what? Delta v is the uncertainty in the measurement of velocity of particle. Uncertainty in the measurement of velocity of particle. Okay, we cannot measure accurately its velocity also, velocity and position also, right? And now there is wave associated with the moving electron. Okay, moving electron, its wavelength is always changes because of change in momentum. Okay, their diagram will be like this. Their wave associated with the moving electron. Okay, in the wave packet. That means it does not have single wavelength. Its wavelength is changes. Then its diagram will be like this there. Okay, this is Heisenberg uncertainty principle. You take the screenshot and note it. And is it clear, students? Is it clearly? Are you hearing? I'm going to erase and I will continue. There is one more last topic. That is a photocell. What is a photocell and what is its use? This is the last topic. Okay. After that, we will discuss few problems and we will close. When it come to you, this eraser will not work. Right. And let us go for one more topic. And what is that photocell? It is the last topic in this chapter, right? Okay. What is photocell? What is a photocell, right? And what are their uses that we are going to discuss? Okay, photocell is a device which converts light energy into electrical energy. A device, a device used to okay, a device which converts light energy into light energy into electrical energy. Okay, a device which converts light energy into electrical energy is called as photocell. Photocell is converts light energy into electrical energy. Let us see its construction. It will works when the light falls. For example, this is an evacuated glass tube with a cathode and anode. This is cathode and this is anode. And this is connected to some battery negative terminal, and anode is connected to battery positive terminal through the microammeter. Okay, this is a plug key and this is a rheostat. Along with that, we are connecting some microammeter. It can measure the current. This is the positive terminal of the battery. This is the negative terminal, and the light is allowed to fall. Light is allowed to fall on the cathode. When light falls on the cathode, then what happens? Then electrons releases from the cathode. Then that electrons will passes travel towards the anode, and due to that current will passes. This will works only when current passes through it. Okay, a device which converts light energy into electrical energy is called as the photocell. Okay, next one is what are the uses of this photocell? Actually, these photocells are three types are there. We will discuss these photocells in the another chapters. And just now, what is the photocell and what is the use of the photocell that we will discuss in this chapter. Okay, and its clear explanation one more time I will give later, right, in another chapter. Okay, and applications. What are the applications? What is the uses of these photocells? Okay, photocells are used in burglar alarms. Okay, these are used in burglar alarms. Okay, this is the first use. Second one is it is used to count the number of persons entering into room or auditorium. Number of persons entering into auditorium, okay, or the room. Next, it is used as automatic switch. Automatic switch for street light. For the street lights, this can be used as automatic switch. And it is also used in the reproduction of sound, in producing special sound in cinematography. We will use this. These are the applications of photocell. Now we will discuss few problems. I'm going to erase, you note it. With this, the concept of the dual nature is completed. Okay, let us discuss two, three problems and then after that I will close. We have more three chapters to complete, right? Okay, let us go for the problems. Right, I am going to explain one problem. Previously, just now we discussed also. I gave some problems to solve. Nobody is solving the problems and nobody is submitting the notes. Nowadays, you are become so dull. I don't know what is the reason. Right, let us start. One question. Whatever the problems that I am telling, and all are the previous problems, very important problems. Photoelectric, the photoelectric cutoff voltage in certain photoelectric experiment is 1.5 volt. What is the kinetic energy of photoelectrons emitted? What is the kinetic energy of photoelectrons emitted? This is our question. Right? Now try for the solution. What value they give in the question? Photoelectric cutoff voltage in certain photoelectric experiment they give. That means cutoff voltage cutoff voltage means stopping voltage actually. Stopping voltage or the cutoff voltage both are same. Stopping voltage or the cutoff voltage they gave us 1.5 volts. What they are asking, kinetic energy of emitted electrons they are asking. Right? What is the answer for that? Solve it. You know it is very easy problem. Next problem I am going to write. In the graph, which metal? There are two questions are there. A, in the graph, which metal has high work function? High work function. This is the first question. Justify your answer. You should support your answer. B question is that in the graph, in the graph, which metal has high cutoff or threshold frequency? Which metal has high cutoff or threshold frequency? Right, let us go for the solution. Who will tell this one? Answer Priya Mato. Kinetic energy value how much? The one electrode which is connected to the negative terminal, one electrode which is connected to the one metal plate which is connected to the negative terminal of battery, it is the cathode. Okay, another one is the positive one is the anode. Cathode, from the cathode electrons will emit when light falls on it. All the other members, why you are not giving the answers? Hmm? Right. The maximum kinetic energy formula is what? EV naught. Okay, we write here like this. E into V naught is 1.5. 1.5 volts. Then kinetic energy directly we can write 1.5 electron volts. That's the big in electron volts. If you want to write in joules, substitute the electron value, right? 1.5 into 1.6 into 10 to the power of minus 19 joules. Okay. 1.5 into 1.6, what you will get? Right? 2.4 into 10 to the power of minus 19 joules. Right. Okay. Right, Priya Mato. Now, next, let us continue. Try to answer for the next question. 1 minute, take the time. In the graphs, which metal has high work function? Do you know the formula for the work function? Huh? Work function. Actually, we can also find this work function like this in the figure. For example, they gave the diagram like this. This is for A, this is for B, this is for stopping potential, this is for the what? Frequency. This is nu naught, this is nu naught dash. Right? You do the extension for this y-intercept, what it will gives in this graph. Stopping potential versus frequency graph. You do the extension at here. The A graph y-intercept is C1. For the B graph y-intercept is C2. What the y-intercept gives in this? Can you tell what y-intercept gives in the V naught new graph? Y-intercept gives y-intercept. When you do the extension, it will intersect the y-axis. That will gives the what? Do you know formula? V naught formula, you know. H by E into nu plus minus H nu naught by E. Do you know this formula? H by E of nu minus nu naught. This is similar to y is equal to mx plus c. Right? Y-intercept gives work function by E. Y-intercept gives H nu naught by E. That means work function is denoted with phi naught, na? Work function by ई दैट मीन्स किसका वाई इंटरसेप्ट ज्यादा होता है उसका वर्क फंक्शन भी ज्यादा होता है. वाई इंटरसेप्ट इनवर्सली डायरेक्टली प्रोपोर्शनल टू वाई इंटरसेप्ट डायरेक्टली प्रोपोर्शनल टू वर्क फंक्शन. इसका वाई इंटरसेप्ट ज्यादा होता है उसका वर्क फंक्शन भी ज्यादा होता है. इसका वाई इंटरसेप्ट ज्यादा है इसका फिगर में बी का, राइट. C2 greater than C1. That means work function of B metal is greater than the work function of A metal. Is it right? Solution is completed. Only for the A completed. Have you understood this? Have you understood this? No, not understood. Students, have you understood? Answer. Right. From the figure, from figure directly we can write. Do you know this? Right. No not less than no not from figure. That's why which one has less cutoff, high cutoff frequency? High cutoff frequency, which one has? High cutoff frequency. First question is what? High work function. High work function from metal B. Is it right? Answer. Metal A or metal B? Metal B. High threshold frequency. This one only threshold frequency. X-axis cutting na. That is called as threshold frequency only. Metal B has metal B has metal B has high threshold frequency. Is it correct? Which one I have to repeat? Second question. Second question is depends upon the second question depends upon the okay. I will explain. You take the screenshot. I am going to erase left side. What they are asking in the second question? That is, it was very simple. Okay, see here. What stopping potential versus frequency graph gives? You know, according to Einstein equation, H nu, Einstein equation equal to H nu equal to W. Phi naught plus K. Okay, phi H nu, phi naught is H nu naught. K is EV naught. Then from that H nu minus H nu naught is equal to EV naught. From this V naught is equal to, we will get as H by E into nu minus H nu naught by E. This is the formula. In this V naught versus nu graph we are drawing. This is similar to y is equal to mx plus c. That means y intercept is H nu naught by E. In V naught nu graph, y intercept is giving y intercept what it indicates. In V naught new graph, y intercept indicates this is metal A, this is metal B, this is nu naught, this is nu naught dash. This is the frequency on x-axis, stopping potential on y-axis. What they are asking it here, that in the given graph, which metal has high frequency? There are two metals, A metal, B metal. A metal graph, B metal graph. Out of these two metals, which metal has high work function? Our question. High work function. Actually, in V naught new graph, okay, when you go for V naught new graph, in V naught new graph, if you find out the y intercept what it will gives? Y-intercept it will gives y-intercept gives C. That is equal to, we know formula V naught equal to H by E into nu minus nu naught, or V naught equal to H by E into nu minus H nu naught by E. This is similar to y is equal to mx plus c. This C indicates H nu naught by E. H nu naught by E. That is y intercept gives work function by H nu naught is work function. That means y-intercept directly proportional to work function. Then the y-intercept for which metal it is more, you do the extension for the first metal and second metal. Then this is C1 for the A metal, for C2 for the second metal. Then otherwise you write Ca or Cb, Ca less than Cb. Okay, that's why work function of A is also less than work function of B. That means metal B has more work function. Metal B has more work function. Okay, and the second question is that which one has more threshold frequency? Work function formula we know H nu naught. Okay, work function proportional to nu naught. Which one has more work function? That one has more frequency also. If work function is more, frequency is more. That means work function of B is more means frequency of B also more. Or directly from the figure also you write nu naught less than nu naught dash. That means this is nu naught is less, this is more. When you go to right side, nu value increases. This is less, this is more. Nu naught dash is more from the figure. Nu naught dash is more means threshold frequency for B is more. Right? Metal B has more threshold frequency. Not understood or understood? Is it clear? Students, is it clear now? Next, let us go for one more problem. Okay, is it clear? Okay. Good, Priya, Bhumika, Aditi. Right now I am going to continue. Let next question I will give. We are discussing the problems. I will continue the problem. Next problem is also previous question. Okay, and you all solved the problems also. Next question is that the maximum kinetic energy, The maximum kinetic energy of photoelectrons. The maximum kinetic energy of photoelectrons gets doubled when the wavelength of when the wavelength of incident light incident on the surface changes from lambda 1 to lambda 2. Derive the expression for threshold frequency. Threshold frequency and work function of metal. This is our question. The previous 3 marks question. What they gave in the question and what we have to find out. Let us go for the solution. And the maximum kinetic energy of photoelectrons gets doubled. Look at here. Photoelectric effect is what actually? This is a metal. This is a metal. Whenever the light is incident on the metal, this light has the photons. Okay, photons are incidenting on the metal. Then after gaining one photon, each photon is absorbed by one electron. After absorbing, the electron will come outward from the metal surface, and after that it will go with some kinetic energy. The absorbed photon energy used by the electron in two ways. Part of energy used to come out from the metal surface, that is called as the work function. And the remaining energy used as kinetic energy. The electron in the metal gains the photon energy Hν, used in two ways. Little bit energy used to come out from the metal surface, that is the work function. Remaining energy used as the maximum kinetic energy. This is the Einstein photoelectric equation. Is it right? Then maximum kinetic energy of photoelectrons gets doubled when the wavelength of incident radiation changes from lambda 1 to lambda 2. Firstly, the incident wavelength is lambda 1. At that moment, we can consider as the kinetic energy of emitted electron is K1, and when the wavelength of wavelength of incident radiation. Here the light is incidenting. This light has certain wavelength. That wavelength changes to lambda 2. The wavelength of incident radiation, this is radiation incidenting on the metal, its wavelength changes from lambda 1 to lambda 2. Then at the moment the kinetic energy of emitted electron is emitting it here. Then incident wavelength changes means emitted kinetic energy also changing, that is from K1 to K2. Then question is that first derive the expression for the threshold wavelength. Lambda naught is what? Or the threshold frequency is what they are asking. Derive the expression for threshold frequency. Threshold wavelength. Once again, I will see. It's not threshold frequency. They are asking the threshold wavelength. They are asking the threshold wavelength. If you know threshold wavelength, easily you can find out the threshold frequency also. Okay. Because you know nu equal to C by lambda. Nu naught is C by lambda naught. This is threshold frequency. This is threshold wavelength. When you know threshold wavelength, you can find out the threshold frequency. When you know threshold frequency, you can find out the threshold wavelength. These two are unknown. Out of this, if anyone knows, other one we can find out easily. Right? Lambda naught is what? Threshold wavelength is what? The second question is that work function is what? Work function is the phi naught. Okay. Work function phi naught is the work function. 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 Phi naught When light wavelength changes from lambda 1 to lambda naught, work function does not changes because work function depends upon nature of metal. Nature of metal. This work function is constant for, in this case, work function is constant. Why? Because the wavelength of light is changing. Metal we are not changing. Wavelength of light changes from lambda 1 to lambda 2. That's why work function does not changes. Then Einstein photoelectric equation, what you know? Einstein photoelectric equation. Do you know Einstein photoelectric equation? H nu is equal to, right, phi naught into Ke max. In the question, they not gave the frequency. So we convert into wavelength. C by lambda is equal to phi naught plus Ke max we have to write. This is equation 1. No, it is general equation. No need to give it as equation 1. It is the formula that we are using. Okay. What we wrote here, nu is equal to C by lambda we wrote. Now what we have to do it here, first case we can apply. This one we can apply for the first case. Okay. First case is what? Lambda is the lambda 1, kinetic energy K1. Then we write HC constant, lambda become lambda 1. Work function also constant, kinetic energy is K1. Okay, from this K1 formula you write. What you write? C by lambda 1 minus phi naught we write. This we can consider as equation 1. For the second case we can apply. HC by lambda become lambda 2 here. Work function does not change. Kinetic energy become now K2. Now here we have to write the K2 formula. Hc by lambda 2. No need of K2 formula. But the K2 they gave us, you see here, the maximum kinetic energy of photoelectrons gets doubled when wavelength of light incident on the surface changes from lambda 1 to lambda 2. When lambda 1 is the wavelength, then the kinetic energy is K1. Okay. And when the wavelength is changes to lambda 2, the kinetic energy become, what happens kinetic energy? It become K2, but it becomes doubled. Doubled means initially K1 means it will become 2K1. This we substitute it here. K2 is the 2K1. We understood. If you have any doubt, you can ask me. That is equal to phi naught plus K2 we write as 2K1. Now we substitute the K1 from equation 1. This we are writing from equation 1. Till now, if you have any doubt, you can ask me. Are you understanding clearly? Okay. I'm going to erase the left side and I will continue. But we have to simplify it. Hc by lambda 2 is equal to phi naught plus 2 into Hc by lambda 1 minus 2 phi naught. Right. And this one we will take to left side. Hc by lambda 2 minus 2 Hc by lambda 1 is equal to right side phi naught minus 2 phi naught minus phi naught. Then from this phi naught is equal to what you will get? C is common at here. You multiply with minus also. you will get minus hc by lambda 2 plus 2hc by lambda 1. Then hc is common at here. Then we will get 2 by lambda 1 minus 1 by lambda 2 we will get. Okay, this formula we will get. You simplify this one. hc into we will get as 2 lambda 2 minus lambda 1 by lambda 1 lambda 2 we write. This is equation. We not consider till now any equations. This is 1 and this we can consider as 2. This is the formula for the work function. And they are also asking the formula for the threshold wavelength. Then how we can find out the threshold wavelength? Work function we calculated. Next threshold wavelength they are asking. How to find out the threshold wavelength? Then to find the threshold wavelength we have the work function basic formula. Okay, what you know work function basic formula? We know work function formula is h nu naught. This we write as hc by lambda naught also, where lambda naught is called as threshold wavelength. Then you compare both of them. What you will get? Okay, we will get h from equation 2 and 3. From equation 2 and 3, left sides are equal, right sides we can equate. Then hc by lambda naught equal to 2 lambda 2 minus lambda 1 by lambda 1 lambda 2 into hc also there, I forgot. This hc cancel. Then lambda naught is equal to what you will get? Lambda 1 lambda 1 lambda 2 by 2 lambda 2 minus lambda 1 you will get. This is answer. Any doubt? Can Priya Mato, sir, can wavelength of same incident light ray be different? Wavelength of incident light ray, it will be not different. For example, you see different colors you take. For example, one the first blue color is allowed to incident. The blue color has the wavelength lambda 1. Remove the blue color and allow the red color to incident. Different colors have the different wavelengths. Okay, and blue color wavelength does not changes. Always the blue color frequency and wavelength is same. But whenever it will goes to other medium, it will be changes. It may be changes. Okay, but in one medium, its wavelength is same. Then when the color of the light changes, then different colors having the different wavelengths. And if you take the VGR, then when you will go to right side, the wavelength is increases. The highest wavelength for the red color, the lowest wavelength for the violet color. Here we are changing the incident wavelength, means we are changing the color of the light. Have you understood? I am going to close the meeting. I am going to close the lecture. Okay, with this dual lecture is completed, and practice properly and solve the example problems and exercise problems. Okay, tomorrow we will start the next chapter.